So let's apply the discriminant here and see if this is actually factorable. In other words, are we going to just waste our time trying to find factors? Let's see. All right, so B is going to be a -4. A is going to be a +1. C is going to be a 2. Let's see if it's factorable. All right. Let's see. X1 first. So -4 times -4, +16. -4 times A times C. So I got, remember my little plus negative, I like doing that, make it more clear in my mind. Nice. So this is a -4 times a 2, yeah? Careful here. I got a 16 plus a -8 now. That's a +8, huh? Is 8 a perfect square? Go to Christmas tree. So listen up. In other words, there's no such number of times itself that becomes 8. We have a problem. So now, how are we going to solve this? How are we going to solve this equation? Before we figure out how to solve it, let's do this day in history. Give me the lights, Mr. So, we have a problem. We can't factor this. Therefore, we can't solve it by factoring. Okay? What can we do to, is there any way we can get x by itself? In other words, can we do something to both sides of the equation to get it by itself? Is that possible? What should I do? Okay, let's see. Let's see if we can get x by itself. We might have a problem, though, because I have an x squared and I have an x to the first, and that's going to create a problem. But let's see if we can do something here. Watch. Check it out. Remember, that's x to the first, right? So that's going to create a problem trying to get x by itself. But let's try Valencia's idea. Subtract 2 to both sides, you said? Yeah. All right. Let's see if it works here. Watch. Don't write this down. Just pay attention for now. Okay? I'll tell you what to write down. I want you to just listen. I want to set up the problem for you before I teach you one of the most hardest, most difficult lessons. So, let's just say subtract 2. Let's see what happens. So, I end up having x squared minus 4x equals -2. All right? Okay, so we still have an equation. It's legitimate because we subtracted 2 from both sides. We tweak the equation. It looks like this now. How can I get x by itself, though? Okay. Remember, I can do whatever I want to both sides so long as I do it to both sides, and the equation still stays as the equation. So let's see what we got. That's gone. Let me bring on the equal sign. I have x squared equaling, are these like terms? No, so I have 4x minus 2. Or you say making it worse. You're seeing the problem, though. How can we? Or what's the problem? Yeah, the problem is that you have 2 different kinds of x's. You have the x to the second, x to the first, and you want to get x by itself. You can't really do it because you have 2 types of x's. One is raised to the first power, one is raised to the second power. You can't combine them because they're not like terms. That's the problem. Is there any way out? Is there any way out? There is a way out. Talk to me. Go ahead, Alan. Let's see about what I'm going to do kind of relates to what you're saying. Let me see, watch. Let me erase all this. Put the +2 here. It was a +2, right? Yeah, okay. Now, the beautiful thing about math is that it involves pure logic, symbolic logic. the rules of thinking. And powerful thinkers in the past, using the God-given faculties of rationality and logic and thinking, meditation, have come up with a way to solve an equation like this. Understanding the logic of an equation is kind of like a balance, right? When you have a balance, you can do whatever you want to the left side so long as you do it to the right side and the equation stays balanced. No matter what you want to do. If it gets you excited to multiply the left side by 5,000, knock yourself out, so long as you multiply the right side by 5,000. If it gets you excited to divide the left side by 2, knock yourself out, so long as you do the right side. You can do whatever you want to an equation so long as you do it to both sides. It's like a balance. That's the key to what I'm about to teach you right now. Whatever you do to one side, you got to do the other. By the way, the equal sign right there in the middle. Huh? Here's the left side, right side 0. So watch what we're going to do now. Here we go. This method I'm going to teach you is called completing the square. So on your notes, let me type it up. So we're going to put, we're going to transition into our notes now. Even though this is an example from warm-up, we're going to go right into our notes. Entitle your notes, Completing the Square. Completing the Square. So completing the square, let's solve the equation using this method. Okay. So give yourself some space on the right of your notes. On the right, go to write steps. There's very peculiar the steps that I'm going to show you. I'm going to describe the steps right off to the side. And I want you to stay with me. Okay? And write the steps down on your own notes. You'll see this on the final. All right. So what we want to do is, let's compare, let's write the standard form of a quadratic right above it. I'm going to put it in red, actually. Remember the standard form is ax squared plus, what's the next one? bx plus c equals 0. Okay, so let's compare that. We know our a is going to be 1, b is going to be -4, c is going to be 2. Here we go. The first step you want to do is subtract c, or let's put, take c to other side. Break on 2 to the other side. Not on the doors. Let's take c to the other side. How would we take c to the other side? Valencia gave us that example or that suggestion a little while ago. What was your suggestion, Valencia, a little while ago? The first step. Remember you subtract 2, from both sides. So do that with me. Look at that c. I'm taking c to the other side, but I have to do it in such a way that I have to do something to both sides of the equation. Okay, watch what happens. I have x squared minus 4x equals -2. Okay, no harm, no foul, no bloodshed yet. Nothing too scary, right? That wasn't that bad. Everyone's okay. You guys are still alive. I'm going to try to take the scariness out of this lesson. All right. That's step 1. I'll put them in bullets now. The next thing we're going to do is, now this is the funky part now, ready? We're going to add b divided by 2 to the second power to both sides. That's weird. But remember I said when you have a balance, the scale balance, you can do whatever you want to both sides, so long as you do to both sides. Well, we're going to add b divided by 2 to the second power to both sides, and it's going to do something very special to this equation. It's going to allow us to get x by itself shortly. Watch. It's genius. And it's pure logic, too. Watch. So, b over 2 to the second power. b over 2 to the second power. Let's see. What is b? 4. Right, negative 4. So let me come over here. So b over 2 to the second power is going to be really b, let's see, negative 4 divided by 2 to the second power. And what does that become? Let's see. Yes, so negative 4 divided by 2 is negative 2. And what's negative 2 to the second power? Let's see, negative 2 times negative 2, positive 4. So there it is. I'm going to add that to both sides. That's b divided by 2 squared. That's what I'm going to do. I'll do it to the left. Remember, it's a balance. I also have to do it to the right. I highlighted in blue. That's the key step now. You're asking why the heck b over 2 to the second power? Why of all numbers in the universe, why b over 2 to the second power? Hold that question, you're going to find out right now. So we added the same amount to both sides, and that's logical. You have an equation, you can do anything you want to both sides. Watch what happens. Let's simplify now. We have, let me go back to red here. We have x squared minus 4x plus 4. That's a trinomial, right? On the right side, I have, what's negative 2 plus 4? Positive 2. So far, so good. You guys ready? Good. The next step, ready? I'm putting the steps in bullet points here. The next step is I'm going to factor the trinomial. Factor the trinomial. What's up, Oriana? On the left. Factor trinomial on the left side. Guess what? It's factorable. This trinomial on the left side of the equation is factorable, believe it or not now. Remember when we did the discriminant for warm-up, it wasn't, the original trinomial was not. This trinomial is not factorable. But since we added b over 2 squared to both sides, we now have a trinomial that's factorable. Can someone give me the factors? What would they be? 2 and 2, huh? Positive or negative, huh? Look at this. X minus 2 times x minus 2. Those are our factors. Hey, x times x is x squared. Negative 2 times negative 2 is positive 4. Outside to inside is equal to negative 4. We're rocking and rolling. We'll move it right along. With me? I'm really liking what I'm seeing here. So, here we go, here we go. The next step is rewrite the two binomials as one binomial squared. One binomial to the second power. do you guys think I mean by that? Before I do it, I wrote it down. What do you think I mean by that? Rewrite the two binomials as one binomial squared. Thanks. Go ahead. Nice. Look at x minus 2 times itself. Look at it. This is x minus 2 times x minus 2. That's x minus 2 times itself. Anything times itself is itself to the second power. So look at what I'm doing. This is really x minus 2 to the second power. Is it not? Doesn't that make sense? That makes sense to me. I don't know about you. Anything multiplied by itself is to the second power. Okay. Cool. Moving right along.
I have a question. What if it's like 4 and then 1
At that point, it wouldn't be square. It'd just be, you couldn't do anything. It was just two factors. But the thing is about this method, what's the method called? What's the title? See, it's always going to be a square, 2 binomials to the second power. This is always going to result here. That's the beauty of this method. In other words, you'll never have these different if you follow the directions right. Good question. I like how you're thinking. Next step. We're almost done, gentlemen and ladies. I'm used to classes with a bunch of guys. Let's isolate now x. Believe it or not, we can isolate x now. How do we get rid of the second power? Remember our days with the Pythagorean theorem? How do you get rid of second power? What's the opposite of squaring? Not squaring. Square rooting, huh? Okay, what I'm going to do to get rid of the second power, remember our days of two months ago of Pythagorean theorem? To get rid of second power, you square root. I'm going to square root the left, and I'll square root the right. We're in business now. Watch what happens. Second power and square rooting cancel each other out. So all I have now on the left side is x minus 2. On the right side, I have positive and negative square root of 2. The reason why I say positive and negative is because when you take a square root, there's actually two numbers that make up that number. Let me explain. We'll write it down for now. Watch this. Why is there a plus and minus in front of that square root? The reason why there's a plus and minus is because, don't write this down. When you take the square root of any number, like say 4, what number times itself becomes 4? There's also another number that multiplied by itself becomes 4 too. You guys know that? There's another number times itself that becomes 4 besides 2. There it is, negative 2, huh? Isn't negative 2 times negative 2 positive 4? Positive 2 times positive 2 is 4 also. That's why if you take the square root of 4, it's actually a positive and a negative 2. There's two roots to a square root, a negative one and a positive one. So when I wrote down right here, positive and negative rad 2, that's because there's two roots to it, a positive one and a negative one. Because a negative times negative is still positive. Positive times positive is still positive. Now, the square root of 2, unfortunately, is an infinitesimal. It's an irrational number. We're just going to leave it as square root of 2 for now. We're going to leave it as the exact answer. Remember when we did Pythagorean theorem? We did that. We broke down radicals. So we're going to leave it as an irrational number right now. Just leave it as square root. We're not going to approximate. But let's get x by itself. X is still not by itself. What can I do to both sides and get x alone? Add 2, huh? Exactly. Let's add 2 to both sides. Let's add 2. You guys with me? Watch this. If I add 2 to both sides, look what ends up happening. Look what I get. I get, this is gone. And on the right side, I have x equaling now 2 plus and minus the square root of 2. There's my solutions. These would be my exact solutions because I didn't punch in square root of 2 in the calculator. So these are my exact solutions. If I wanted the approximate solutions, what I'd do is I'd hit square root of 2 in my calculator and give the 2 solutions. In other words, the approximate solutions, I'm going to abbreviate approx. Approximate solutions are 2 plus the square root of 2 and 2 minus the square root of 2. Let me punch those into the calculator. Watch. I'll let you write that down. Let me go to my online calculator and punch in 2 plus the square root of 2 and 2 minus the square root of 2, and I'll round to the nearest 10 for now. So this would be my exact right here. We're done. Technically, we're done. But if you want to kind of know what numbers these are, I'm going to punch this in the calculator and what's approximate because of these long decimals. Watch. Let me go to my online calculator. So 2 plus, watch this, the square root of 2, there it is. Let me hit equal. I'll round the nearest tenth. So it's about 3.4. That's one solution. Come back over here. So one of them is approximately 3.4. So x then is approximately 3.4. And let me do the 2 minus the negative 2. The 2 minus rad 2. So let me clear this. 2 minus the square root of 2. That's some infinitesimal. See what the calculator spits out. To the nearest tenth, I look at the tenth place. To the right of it, it's 5 or bigger, so it's about 0.6 to the tenth place. Come back over here. Here we go. So x is approximately 3.4 and 0.6. So these are your approximate solutions. These are your exact solutions. You got to know both. Now that's just an intro. I only did one example, very slowly, very slowly. I'm going to go more in depth on Monday of this. I'll not really know more in depth. I'm just going to cover a few more examples to get some fluency and some familiarity. And then Tuesday will be our last lesson of the whole year, which is on graphing a parabola, graphing a quadratic, and we're done. Wednesday and Thursday will be workshop, getting all your final assignments done, and your final test, which is going to be very short. But we're pretty much at the end of the road. Okay? Any question on this? That took longer than I thought.